Hi everyone, welcome to my presentation at CodeSec Days. My name is Mackenzie Jackson. I'm a security and developer advocate at GitGuardian. And if you've heard me speak before, you've probably heard me talk a lot about leaked secrets, and particularly maybe how adversaries find these leaked secrets, how they use them, or how they kind of sprawl into different places. Today I want to cover a different type of topic, and that's remediation of these secrets. So I think most people understand that when these secrets leak out, it's a big issue. And therefore, the primary objective should be identifying where they are, finding these secrets. But actually, that's more or less the easy part. The difficult part is actually being able to effectively remediate them, and particularly at scale. So that's what I really want to focus on in this presentation. And we're going to have a look at the methodology that we use at GitGuardian to help remediate that process. So let's get started. I always like to start off with talking about what are secrets. So I'm sure everyone probably understands this already, but when we're talking about secrets, we're talking about digital authentication credentials. And typically these will be things like your API keys, your credential peer, security certificates, anything that kind of provides access to third-party services, allows us to ingest data or decrypt data, or allows us to connect to different systems. What's really important here is that these secrets are made to be used programmatically. Now, what that means is that they're not meant to be used by humans. They're meant to be used inside source code. They're meant to be used by machines. And this makes it interesting because these secrets are then, therefore, a very high candidate to end up in places like source code. And when secrets end up in source code, they inevitably sprawl into lots of different places. And then trying to find them, trying to know what to do with them when they inevitably do sprawl into these places is a really big challenge. So let's start off by talking about why do secrets leak? And perhaps you've heard this before, but I think it's important to go in, and I'll drill down onto it any chance I can. I think most people listening will understand that a secret like an API key is really sensitive, and it shouldn't end up inside your Git repository. It shouldn't be hard-coded in your application. We can probably all agree on those things. So why then do they end up in source code? And most developers will agree that they shouldn't be in source code. So why does that happen? Well, it's not what people think. It's not because of junior developers or anything. It's just because of really how Git works and how all of our systems end up being connected to each other. I want to go through a scenario. This is a scenario when I was a developer that happens a lot. We're working here on the screen. You see a Git tree, and you have your main branch. And what typically happens is you will create features off this main branch, and you'll work on it by yourself or perhaps with a team, and then you'll merge that back into the main branch. But essentially, when you create a feature branch, you're really working pretty much independently. So imagine this scenario. Someone says, they go, hey, we need you to build out a new feature. And this feature, we need you to connect to an AWS bucket or whatever it is, any kind of service. And it's like, okay, the first thing I might do is just hard code those credentials in that I need to connect to that service, that bucket. And I know that I'm going to remove them later, but I'm just quickly checking to see that I can get things working. I want that first version just of everything done, right? So I hard code it all in, I work quickly, I see it working, and then what I do is I start using better practices. I'll remove those keys, I'll put them in as environment variables, so on and so forth, and I'll develop from there. But what people don't understand is that Git maintains a history of everything that we do on every single branch at every given moment. And what that enables us to do is move back between different commits really easily. If we break production, we can quickly go back to a version that works, right? And that's in the name, version control systems. But this also has a bit of a challenge, is that everything you do has breadcrumbs of it. So if I hard code a secret on a development branch, even if I remove it later, it's still in the history. And what's more scary is that when I go to merge that onto the master branch and I do a code review, those secrets aren't visible to anyone. So a lot of people would say, yeah, okay, but sure, if there were secrets in code, we would find them in the code review, and obviously we would deny that pull request or whatever. Well, it doesn't quite happen because it's buried in the history. And the trouble with this is that the Git history, even Git version control systems, they just have a tendency of sprawling everywhere, regardless of it's in the history or not. And it makes it really difficult to find. There are some other reasons too. Uh, in logs or auto-generated files, often like a debug log will have a printer of the environment variables in it. Guess what those environment variables are? Often they're secrets. You will have things like no git ignore in your Git repository, and that means if you have temporary files, for example, a secrets.txt, or those log files, they'll end up inside them. We also see secrets inside template files. So if you create, for example, a Django project, straight away there's going to be keys in there that you need to go in and replace. But if you don't do that, then your keys are going to be visible. And also we just see people sharing secrets on Git because they seem to think that, no, my Git repository is private, therefore it's safe. And I'm going to argue against that in a minute, but this is kind of why secrets end up in source code so frequently and why they leak so often. And we can really see the workflow of this. We have a developer. I request secrets either from like a vault or a secrets manager or from a person. I get those secrets and I code them so they end up inside the Git repository. But then what happens with that Git repository? Well, here's where it gets kind of, the blast radius gets bigger, is that now that Git repository gets cloned into all kinds of places. So it's on your developers' machines. It's being cloned onto multiple developers' machines. It's probably going to be backed up somewhere. It's going to be on wikis. You're going to copy some code on messaging systems and share them between colleagues. You're going to have code on your networks and all of these different places. So your source code ends up kind of sprawling uncontrollably. Not only do you not have any idea, you have no logs of where the source code is, anything that is inside it kind of hitches a ride with it. So secrets end up in your backup systems, in your developer machines, in the messaging systems. And so this is just inevitably what happens. So this is particularly interesting, and this plays into that remediation part because, well, there's only really one thing that you can do when you find a secret. You have to revoke that secret. It can be challenging to do that. Because if we don't revoke it, if we just delete the commit, because you can rewrite Git history, and there's a conversation for another day as to why that's such a pain and it shouldn't be done. But anyway, you can do it. But the secrets have probably already sprawled into different places. And they've probably sprawled into places, developers often will have it on their personal machine and their professional machine. Maybe they'll accidentally put it in their own GitHub repository or other areas like this. And there's no trace of where your source code has ended up. So there's no way of knowing where these secrets are. So that's why they shouldn't be in source code. But it's also why when they do get in there, and they end up in so many different places. So what does it kind of look like? If you're wondering, gee, do I have leaks in my organization right now? Chances are you probably do. And because these systems tend to be private, it's not catastrophic until someone unauthorized gets access into them. But that does happen. But if you're wondering what are the warning signs of this, if you can see any plaintext credentials in your code, in configuration files, if you're seeing plaintext files in your logs, if you're seeing sensitive files in your Git repositories like .env or .pem files, then the chances are you're going to have a lot of secrets in there. Because if that's on the surface, if that's what's visible, once you peel back those layers, it only gets worse from there. And also, if you don't have fine-grained access logs of who has the ability to kind of view the source code, which you probably don't, because the nature of source code is it's meant to be distributed, then you're also going to have issues with where all these systems end up leaking. So what about private source code? Why is it a problem if secrets end up inside private source code? And this is an argument that we have. It's like, okay, I understand why secrets shouldn't be in public source code, right? That makes a lot of sense. What about private source code? Private source code is really bad at doing one thing, staying private. If we look in the news, you'll see that there's massive companies with great security posture, companies like Microsoft, like Samsung, like NVIDIA, that have all had significant breaches of their source code, or as I like to call it, involuntarily open sourced. So we've seen this with lots of different companies. So why does source code of companies with great security end up being distributed? And it's because it's a very leaky asset. We saw a group called Lapsus who was really targeting source code of big companies for a while. And their modus operandum was literally just paying employees of those companies to give them access. You don't know who's got a parking ticket or a speeding ticket or just having a bad day, or their managers just kind of reprimanded them and someone comes and offers you a bit of money to give them access to source code. That can be quite tempting, and a lot of people in the organization will have access to that. But also, you can target lots of different systems. You can target people personally to get access. You can target the hardware and developers' machines. You can target backup systems and other areas. So you have a lot of opportunity to get this source code. The blast radius, the attack surface is really quite large. So that's really one of the main reasons why even private source code is just a terrible place to have these secrets, because it's not going to be centralized to that one location. So how big of a problem are secrets when they get leaked? So one of the things you may know we do at GitGuardian is we actually monitor large code bases like GitHub for secrets. GitHub is the largest kind of database or distribution or location of open source code in the world. There's about 100 million developers that use GitHub, and there's about 1 billion commits every year made to GitHub for public repositories. And GitHub is quite interesting. One of the reasons why GitHub is interesting is even if you don't have a relationship with GitHub in your organization, it's still part of your supply chain because your developers will be using it. It's kind of important for portfolio usage. It's important for them to work on, other projects, hone their skills, to have it acts as a bit of a social media with the community. So you're still going to have some exposure to it, even if you're not using GitHub in your organization. And often your company's source code can end up in GitHub, as we see in lots of different scenarios. So how big of a problem is it? Well, one of the things we do at GitGuardian is we monitor the public activity on GitHub for secrets. Those 1 billion commits I just said, we've scanned every single one of them. So anytime anything happens in public in GitHub, we scan it. And what did we find? Well, last year, if you want to have a quick guess as to how many secrets we actually found, last year we found almost 13 million secrets. 13 million API keys, passwords, credentials leaked on GitHub. And this is an astronomical amount of leaks that we had. So why is this number really so big? And it's all those reasons that we talked about before. How easy it is to have something buried in the history. Maybe you make a project open source that was closed source, but you forget that actually way back in the history, you had secrets hard-coded in there when you make that public. We've also seen examples like Toyota had a breach because one of their contractors accidentally pushed private source code to their personal public repository. And inside that, there were credentials for that. So there's lots of scenarios as to kind of why this really happens, but it's very, very frequent. What we're also seeing is that this problem is really growing. So in 2020, first year we did this study, we found 3 million credentials. In just kind of 3 years, this has grown astronomically to 12.8 million credentials. So, the problem is getting bigger and bigger. And this is also because the amount of people using GitHub is getting bigger and other areas. But the problem, we're just leaking a lot more secrets now. And it's, very, very interesting. But now I want to talk about the remediation part of all of this, because I think now's where it kind of gets a little bit scary. So what do you do when you leak a secret? One of the things we do at GitGuardian is that we like to alert the developers when they leak a secret. So of these 13 million secrets, if we can find a commit author with a valid email address, we'll shoot them an email and say, hey, you've leaked a secret. It's in this location. Here's the secret. Yada, yada, yada. And we then monitor what happens after that. So we'll check in the next few hours, does the secret get revoked? Does the commit remain? We'll check in a few days. And what's scary is that after 5 days, 90% of the secrets that are leaked remain valid. And we'll see other actions taken. Like we'll see people that will remove the commit itself or make the public repository private, hoping that will solve the problem. But the secret is already out there in the wild. We've already found it. Bad people will have already found it too. This is just the reality. And after 5 days, most of it is still valid. And people may think that just deleting the commit is good enough to solving this problem, but it's absolutely not. So this is quite scary, and this kind of led us to the understanding that, okay, remediation is actually a big problem. People don't know what to do when they leak a secret. So what do you do? Well, the one thing that you do, as I've mentioned before, you have to rotate that secret. You have to get rid of that secret and reissue a new one. But this is actually a challenge, and part of the reason why this is such a challenge is just in the way that large organizations kind of operate and work. So let's discuss why it's so difficult to kind of just revoke a secret. A secret gets leaked, you found the secret. Why is it difficult to be able to remediate this in some way? And the reason is that we're all getting huge amounts of alerts if you're in a security team, and you have to kind of narrow down what's most effective. One of the interesting things is at GitGuardian, what we often do is when we introduce our product into a new company, we do a complete scan of their history. And we typically find around about 13,000 secrets in a company with 400 developers. So it's a smallish company, but we'll typically find about 13,000 secrets in there, 1,000 of which will be unique. So this is a huge amount. So now we've got 13,000 alerts that the security team now has to deal with. And in each one of these alerts, you need to find out, okay, is this secret critical? What does it give access to? Is it production or test data? Who leaked the secret? Can I delete the secret or rotate the secret without bringing down the production of our application? How do I reissue a secret? How do I redeploy it? And you need to do this 13,000 times, essentially, right? Or thousands of times, however many that you find. And it's an impossible task. So this is actually why the real problem of remediation is so gosh darn difficult. It's because you need to deal with so many different stakeholders, and you're already drowning in alerts for other priorities. And if you work in a security team, then you're also probably not just focused on secrets, right? You've got lots of other issues that you also need to deal with. So this is a big challenge and a big problem. So how do we actually solve this problem? What can we do? Well, when we find a secret, it's not good enough to just have the secret itself. We need to enrich the information of that secret. What does this actually give access to? What is this a valid secret? We also need to reduce the amount of false positives. Anyone that's tried to do secret detection, you test it out on a small repository, it works fantastic. You put it into a large repository or multiple repositories, and then you just get slammed with false positives. So you need a way to be able to reduce that noise and prioritize it. And doing things like validity checks, making sure that they're valid credentials, this is essential to that. You then need to be able to look into what are the highest priorities of these secrets, what are critical, what are high, and what's a low priority secret. Something like a Google Maps API key. It still shouldn't be there, but it's not quite as bad as an AWS key or something like that. So we need to have all of this different information. We also need a way to be able to streamline the communication with teams. See, when we're dealing in large development teams, it's very complex of how it works, who issues the secrets, who's using them, how they're hard-coded. And you also need to streamline this communication process between everyone to make sure that when you get an alert, you know who's leaked that secret and they have the ability to provide information for it. Without this, you're just going to be drowning in absolutely kind of big alerts. And the final thing that you need to do is you need a way to customize this for you. How the technologies that you use are going to be different, and therefore different things are going to have different priorities. So you need to be able to customize your alerts so that you're getting access to the most kind of relevant information for you. All right, so let's talk about remediating this. What should you do? What should you actually do? You've found a secret, you've leaked a secret, what happens? First thing is just to breathe. The worst reaction is always the first reaction that you have. So the first reaction is you leak a secret is you want to delete it, right? But that's not the correct reaction. So have a breathe. You're not going to be the first person in the organization to do this. You won't be the last. And you just need to act calmly, but swiftly, and you will get through it. So there's a sequence that you really should follow here. So the first thing is assess and prioritize. Assess the type of secret that is leaked, or secrets that have leaked, more likely if you're doing a scan of a large system, and you need to prioritize them in order of what you're going to handle first. Production keys that are valid obviously need to take the top level of that prioritization. Next, you need to bring in the different stakeholders. So if a developer has leaked a secret, or you are the developer, you've got to align with the security team, with the DevOps team. So everyone needs to know, hey, what does this secret do? What does it give access to? What's going to happen if I destroy it, if I revoke it? Next thing is you need to fix the code, right? We need to replace it. We need to solve the problem. How are we meant to be using this? Was it in the history? Was it a mistake? Is this key just hard-coded? Fix that problem. And then finally, the most important step, we need to rotate that secret. We need to revoke access to that key. But this is a challenge because everyone needs to be aligned as to what it does, and all the stakeholders need to be aware of this so that we can move forward without bringing down production, right? So this is the flow that we've developed at GitGuardian and that we always recommend people take. So let's have a look at the automated severity scoring. So this is a very interesting one because at GitGuardian, what we've noticed is that we can't provide blanket rules for everyone because everyone's using different technologies and they might have different prioritization. And you might have systems that are using certain technologies that are absolutely critical. And so you want anything related to them to be prioritized. So what we do in the GitGuardian dashboard is we actually allow you to create custom rules for your prioritization. For example, if it's a valid secret for a cloud provider, well, that's going to be critical. Or if it's a valid secret for a Twilio or a Stripe key or something like that, let's give that the highest level of severity. And you can create these rules so that you can narrow down from the noise and just get the top level that you want to deal with first out the way. The second thing you need to know is, where has this leaked? Now, we know that having keys in private repositories is bad, right? But it's worse to have them in public repositories for obvious reasons. They're public. So the other thing that you need to know is, hey, where is this secret? Is it in a private repository? Is it in a public repository? Is it both? And that's also going to help you, and that's going to affect on those prioritization that you have, is dealing with the public leaks first because they're most critical of what we want to do. So having information to that, and also kind of knowing that was this secret valid when it was leaked, even if it's invalid now. Information like that, especially if it's public, is going to be important. The other thing is, how are you going to organize and align your stakeholders? So we've focused on Jira because we find that that's kind of the task system that most of our users are working with. So what we're able to do is create these automatic Jira tickets that bring together the team in a workflow that they're already used to, right? No point trying to get developers to use security tools. Not going to work, right? So then having that streamlined incident management, so when it goes onto Jira, that you have a ticket ready to go so that you can work forward on that. And another really important feature that's back again with aligning the stakeholders is what we call our dev in the loop feature. And what this is the security team is probably going to be looking at the dashboard and seeing the alert come through, but the developer is the one that handled that secret and made the mistake. So the security team needs to reach out to the developer and ask them a lot of questions about it. But this we can actually automate. So as soon as we find a secret, you can activate the dev in the loop feature, which sends through a survey to the developer or enables them to access the dashboard in a way where they can only see their own relevant incidents. And they can immediately fill out a survey as to what the secret is. And it's quite simple. The survey's not long. It's just, what does the secret do? Is it valid? Have you revoked it? And is this for production systems? And really just with those key questions, you can get a pretty good understanding of what you need to do next. And then obviously you can add any more notes. And what this enables you to do is to streamline that process. By the time the security person is actively investigating this incident, they should have all that context ready to go. And this comes back to that role-based access control So dev in the loop feature can kind of shoot out an email with a survey in it, or the developer has access to a dashboard. But again, only concerning them. No point giving them access to everything. It's really important that we don't accidentally sprawl the problem further by giving everyone access to everything. Being able for a developer to be able to see the incidents that they've done and help in that process, align with all the other stakeholders and remediate it is really important. And other areas is being able to fix the code, right? Being able to know what file this is actually in. Is the latest version still has this issue? Where are we at in the fixing process? This is another area that we need to document and make sure that we take action on. And then finally, we also need to have granular tracking of this. So when we're dealing with critical security incidents like secrets, you need to be able to go back in time and see, was this secret resolved? And this is actually quite important for compliance as well. So not just kind of knowing that, yes, it's got a tick, it's done. Who solved it? What steps were taken? What was the original file? What is the file now? When was it updated? When was the secret revoked? When was a new one reissued? Having all that information in there that you can go back and access, it's extremely important in large organizations and even smaller organizations to have that granular access control when dealing with secrets. And then, of course, we need to automate as much as we can. So the automated playbooks are kind of workflows that you can trigger when a secret is leaked. So do you send the dev in the loop email automatically? Do you allow the developer themselves to heal this incident? So what I mean is, if you trust your developers or you trust certain teams, then you can allow them to resolve the incidents themselves, right? Reissue a new secret, revoke the old one. And then we can actually validate that that's happened. We can see if the secret's valid or not, and we can make sure that they go through the correct steps before they remediate it. So having those automated playbooks really takes the control out of it, because without automation in this area, you're not going to be able to remediate all the incidents that you have. And we have a really cool integration. We're hoping that we're going to have lots more of really interesting integrations like this. But what we can actually do is we're connecting up with CyberArk Conjure, which is a secrets manager, and we can actually link with them securely, so we don't actually get access to your secrets, but we can find out, if your secrets have been leaked, and then Conjure can actually automatically reissue a new secret if a leak has happened. So this is really exciting and kind of cutting edge stuff on secrets management and how we're dealing with that. And we're going to be working with lots of other partners on making sure that we streamline this secrets process as much as possible. So just in conclusion, when we're dealing with remediation, what do? First thing is just breathe. It's going to be okay. This isn't the first time that this has happened, and it won't be the last. Assess the incident and prioritize it. Make sure you're getting the correct information first. Align all the different stakeholders, the developers, the security teams, the DevOps teams. Fix the code, fix the problem, make sure that the secret's not in there. And of course, most importantly, revoke that secret and issue a new one. And that's the process that you need to take with remediation. It's difficult, I know, particularly if you don't have tools in place, but it's really important that you take all of these steps. So thanks for listening to this presentation. I hope you found it useful. Slightly different angle to what we usually do, but I'll be happy to take questions and listen in from you if you have any now. So thanks for listening.